Okay. Well, first of all, good morning, everyone, or good afternoon to those not on the West Coast. Our team is Green Titans, and we are proud to present our project, a Stroke Predictor. Our team members are me, Sophia, as well as Dylan, Jeremy, Shawn, Dami, Jeong, and Alan, who unfortunately could not be here today, but was with us all 3 weeks and was a phenomenal teammate. Plus, of course, our wonderful instructor, Ritum, who guided us through this entire process. So, why a stroke predictor? Well, strokes are a serious problem in the modern day world, especially for Americans. And we created our site with the idea that with only a few very basic pieces of information that you can get from an annual doctor's appointment, you can plug them in to a quick form, and you'll know within minutes whether or not you have a high risk of a stroke. That way, you can either calm your fears, or if we do prove them right, you can go out and seek treatment before the actual stroke occurs.
Now we have our visualizations. First, we have a scatter plot, which compares the BMI and the age and their relation to each other. So from the scatter plot, we could see that there is a trend where the older one gets, the higher their BMI is. And then we also put the average glucose level in there. However, that did not have much of an effect, or it did not have much of a trend, as it is just scattered randomly around the plot. Now we have a pie chart, which shows the relationship of smoking and a stroke. So the blue one would be the people who have never smoked. So you can see that most of the people that we have in the data set have never smoked. And then we have the purple one, which are the people who currently smoke, which is the smallest percent of people here. The big red one is the people that we don't have information on their smoking status. So we don't know if they smoked or not. And then the green one is formerly smoked but stopped. So that's another small percentage of people. Now we have a histogram, which compares the people's smoking status and their average glucose level. And you can see that the people who have never smoked have a higher glucose level usually, or at least in the females. And then the blue would be males, red would be females here. And then you can see just the relationship between the three things.
Up next, we have this multidimensional plot, which compares the age, the average glucose level, and you can see that based on their BMI, the higher it is, the more the BMI is. You can see that younger people typically have a lower chance of strokes, and then higher glucose level has a higher chance of getting stroke. And then also age has a big factor, as younger people have a much lower chance than older people. And then finally, we have the scatter matrix, which compares the age, the average glucose level, and the BMI. You can look in the little table there. You can see each one compared to a different one based on the little column or row that they are in. And this shows that the higher your BMI or your average glucose level is, the higher your stroke risk becomes. Now we are on to our machine learning models, where we will start with the decision tree, which is a tree structure which gives you you put in, ask it a question, and then out comes a node or an answer. And the reason we did not go with the decision tree is because it had the highest percentage of false negatives at 235.
Next up, we have bagging, which ended up being our model of choice, as you'll see later why. It is a very useful algorithm that divides the data into subsets and then runs each subset with a decision tree classifier. That way it can take the average of all the predictions and get the most accurate prediction possible. We did a little bit of tuning and we got very high accuracy. Next, we have KNN, which is a very versatile model, and it is also very useful. It works completely different from bagging, though, because it assigns each data point to a group based on the majority of the surrounding data points, basically a majority vote. As you can see, the false negatives here and false positives are both very low.
All right, now we have Random Forest, which is a model that is created using multiple decision trees, and it uses bagging and other features to help it. Some pros are it's easy to interpret and it's able to handle large data sets well. And some cons are it can't guarantee optimal trees, and it gives low prediction accuracy for a data set as compared to other machine learning algorithms. And the reason we didn't choose decision tree is because it had a decent amount of false positives and false negatives.
Next up, we have logistic regression. And logistic regression is pretty simple. There is basically like, we would plot all the points of the training data, and it would attempt to like draw a line. And I believe the equation is something like 1 over 1 plus e to the x, but essentially it's just a curve that will be used to predict like, so I'm getting distracted. So you can predict by like this machine learning algorithm is primarily used for predicting binary classification problems. Hence, it is very good for our stroke prediction model. And I achieved the best parameters possible with grid search, and then using that, we achieved the 80% accuracy.
Support vector machines are data points that are closer to the hyperplane and influence the positive and orientation of the hyperplane. Using these support vector machines, we maximize the margin of the classifier. Deleting the support vectors will change the position of the hyperplane. These are the points that help us build our SVM. Some pros of support vector machines are fast algorithm and effective in high dimensional spaces. Some cons are it doesn't perform well in large data sets, and it's not so simple to program. After using grid search CV on my model, I was able to find the best parameters to fit my model. We did not end up choosing support vector machine as a model, as the false negatives are fairly high.
Jeremy, you there?
Oh yeah, sorry. Now we have Adaboost, which would be Alan's. However, he's not able to be here today, as Sophia previously mentioned. So Adaboost optimizes an ensemble learning method that was initially created to increase the efficiency of binary classifiers. And we did not choose this one as it had also a decent amount of false positives.
Neural networks is a type of machine learning that seeks to process information in a way that's similar to the human mind. And neural networks is a type of deep learning. For our neural networks, I chose 2 hidden layers, the first with 128 nodes, and the second with 68 nodes. And nodes are placeholders for values. The best activation code we got was ReLU, the epoch's 30, our batch size was 64, and our optimizer was Atom, and we used binary functions. And if you scroll to the bottom, there is a heat map, but neural networks didn't have the best accuracy, so it wasn't chosen. The chart shows that bagging had the best recall, and while KNN was really good too, it was slightly overfitted, so that's why it wasn't chosen. And SVC had a lower test accuracy compared to the training accuracy.
In conclusion, we have spent the past 3 weeks here at AI Camp mastering our programming language Python. Our final model has an accuracy percentage of around 97%, making it very trustworthy and one of the most accurate predictors in the world.
And now, before we conclude our presentation, we wanted to mention how we attempted to do Flask. So Unfortunately, due to the time constrictions, we couldn't finish our Flask. But essentially, what the idea is that the user would input much information about themselves, such as age, average glucose level, all the general information, and then the AI would predict predict whether you were likely to get a stroke or not, which is a binary problem. And the troublesome part that we had was how, like, when you're posting it into the backend, we just had some small errors processing the data and returning it back into the main site. But in the end, it was a very good learning experience for us to deal with servers, and it was a very open-minded experience.